Hello, in this video we find the derivative of an inverse trig function, and what I'm going to start off with is tangent inverse. Now we have a formula that you might want to memorize, is that the derivative of tangent inverse, also called arctangent, x, tangent inverse x, the derivative is 1 over 1 plus x squared. So in our situation, what we have is we have y equals tangent inverse of u, where u is equal to x squared. Then when we take the derivative, y prime will be 1 over 1 plus u squared, u prime. And what's u prime? U prime is 2x. Now usually we don't want to write all that stuff down. So let me start up pretending that I didn't write that down and just look at f prime of x. F prime of x, even I'll write f of x. F of x is equal to tan inverse x squared. F prime of x is found by doing the chain rule, just as I showed above. But tangent inverse of u, that is 1 over 1 plus u squared, but I put a blank space where u goes, and I put in u as x squared. Then I multiply by the derivative, so this is u, and u prime, derivative of u prime is 2x, right? That's what I get. So, a lot of times when we're given the formula, it's tempting to directly write down over here when we do the derivative 1 over 1 plus x squared, but we want to leave a blank space where the x is, if I'm using the chain rule, and put in u where x goes over here, where I have tangent inverse u. Okay, next is we'll simplify this a bit. Since I have a whole expression, 2x, I'll multiply by 1 in the numerator and then and get 2x. And then in the denominator, I have 1 plus x to the what power? Since I'm raising x squared to the second power, then I multiply those and I get x to the fourth. So that's our answer there. So we need to know how to use the chain rule, and we need to know the derivative formula for 1 over 1 plus x squared. So we have that one. Let's check out one more where this problem uses the derivative of sine inverse x. So we have a formula for that. Let me go back to a different color here. Let's go to our formula for the derivative of sine inverse x. So this one, I'm not sure whether we should all memorize this, but maybe. Okay, it's 1 over radical 1 minus x squared. It is still sort of so interesting that you have these inverse trig functions and their derivatives are algebraic functions. Okay, well, to find, I'll just write down again h of x. H of x is equal to x squared sine inverse x. Now, to actually find the derivative, what I'm going to do is use the product rule this time. What's the difference? This time I have a product. You could put a dot there between the function x squared and sine inverse x. And so for the product rule, what I do is I take the derivative of the first term, which is x, or the first factor, which is x squared, and then I leave the second factor untouched, plus then the first factor untouched times the derivative of the second factor. And so the derivative of this first part, x squared, is 2x. We should know how to do that by the power rule. And then we have x squared, and then we just copy and paste the derivative of sine inverse x, and that's 1 over radical 1 minus x squared. Is there anything I can do to simplify? Maybe multiply the x squared times the 1 in the numerator over there, but that's hardly anything different than what I already have. These two examples are from Openstax Calculus Volume 1, and they have work solutions. I just made a video, and theirs are typed, and they're looked over for correctness. And so anyway, but you can go to openstax.org, go to Calculus Volume 1, and look at examples 3.65 and 3.66. They have the solutions written out also. Okay, so that's all we have for today. Thank you. Goodbye.